This program, DFTSHIFT, demonstrates the circular shift property of the DFT and also shows the relation between the DFT and the DTFT. Enter a finite length sequence x of n in this box at the top left. The length of the sequence n is determined by the edit box on the top right here, and for simplicity, the allowed values of n are limited to even numbers up to 16. If the sequence you enter is less than n digits in length, zeros will automatically be appended to the end. If you add more than n digits to the end, they will be truncated. You can also adjust values of x of n by dragging elements of the sequence up or down. The white portion of the top display shows x of n, and the shaded portions on either side show the periodic extensions of this sequence. The lower panels show the magnitude and phase of the DFT with n solid symbols, and clicking this control shows the DTFT as well. Clicking the color control here puts the DFT points in color. In a supplementary section of the text, we derived the fact that the entire DTFT can be reconstructed from the sum of n periodic sinc interpolation functions, each shifted by 2 pi over n and scaled by the corresponding value of the DFT. If x of n is minimum phase, as it is here, thin gray lines appear that show the magnitude of these periodic sinc functions. You can shift the sequence by dragging in the plot, by adjusting the slider, or by entering a value in the edit box. The magnitude and phase of the DFT and the DTFT change accordingly, and by shifting the sequence, you can show that circular shift of x of n is equivalent to a shift of the entire periodic sequence modulo n. You can also use the player controls down here to step the sequence one at a time, or you can animate the shift continuously to the right or to the left and change the speed of animation with this control here. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.